I just finished grading your quiz number 4. Now I'm going to go over the quiz number 4. I gave you 10 problem and I'll try to finish the tutorial in 10 minutes because I'm extremely tired. But if this tutorial doesn't help, ask me tomorrow in the class because I'm going to go real fast. Problem number 1, I ask you, I put them together. One is the projectile motion, one is the dropping. So you have a height which is 30 meter. You are 30 meter above the ground, and you throw a ball with 25 meter per second upward, which is 90 degree, right? That's your initial velocity, right? So then this ball will hit the ground at time ta. Now another person uh, at the same time, at the same moment, right? Instantaneously, simultaneously, drop another ball from height h, so that the TB is equal to TA. That means if you find TA, you find TB, and vice versa. No, let's find TA because it's easy to find TA. So D is equal to VAT plus half AT squared. This is negative 30. This is 25T minus 5T squared. So 5T squared minus 25T minus 30 is equal to 0. So you can divide everything by 5. So T squared minus 5T minus 6 is equal to 0. So T squared minus 6T plus T minus 6 is equal to 0. So T factor out T minus 6 and plus 1 factor out T minus 6. So T is equal to 6. So the object is in the air for 6 seconds. So you know TA, which is 6 seconds. By knowing TA, you know TB. Okay, so how can that help? That helps very easily. So D is equal to VIT plus half AT squared. And that is for this scenario, to find this height. So D is height. VIT, when you drop something, is 0, half, 10, and T is 6 squared. So height is equal to what? Half, 10, 36, 18. 18 times 10, 180. So height must be 180. If you drop this one from 180 meter above the ground, they both will touch the ground exactly at 6 seconds. This one will touch the ground at 6 seconds. This one will touch the ground at 6 seconds. That is problem number 1. Now let's go problem number 2. Similar problem, but this time I ask you something else. So again, I'm keeping the same thing. Keeping what? This is 30 meter. I'm not drawing to the scale anyway. So this is 20 meter per second. You throwing up with 90 degree with respect to the horizontal. This is ground, and this is the rooftop. Okay. So what we are trying to find, we just found before that the time over here is 6 seconds. This problem, we are trying to find this very simple thing. When it drops over here, it creates the impact velocity. Impact velocity is happen at 6 seconds. So I don't have different color chalk. So what we are trying to, we're interested is impact velocity. Okay, impact velocity. So what is the impact velocity for object A? Okay, at the same simultaneously, another person will drop it from where? Another person simultaneously, another person will drop it from height h. So that impact velocity B would be equal to impact velocity A. So eventually, basically, impact velocity A is equal to impact velocity B. So it seems like it's easy to find impact velocity A. Why is that? Because we have everything. VF is equal to VI plus AT. So what is VF? Impact velocity. At what time? VA is 25 minus 10. What time impact velocity? 6 seconds. So VF is equal to 25 minus 60. So my negative 35. Impact velocity of object A is negative 35 meter per second. So that impact velocity of object B must be negative 35 meter per second. So impact velocity is equal to vi cos at. Now, impact velocity of object A, object B, this is object B, we are trying to find the height. Object B must be 35 because both of them impact velocity. When you drop something is 0, so negative 10t. So the time is 3.5 seconds. We know that d is equal to half at squared. Now, d is the distance that we are trying to find. Half 10 and 3.5 is squared. So distance is 5 times 3.5 is squared, 61.25. So this is 161.25. So what are we trying to do? We are trying to find that if this is height 30 meter and you throw something with 25 meter per second, right? The impact velocity of A, in order for impact velocity to be, if you drop this object from height h, this impact velocity we found 35 meter per second. This one will also be 35, negative 35 meter per second. If this one, instead of 30 meter, if this one dropped from 61.25, so this one has to drop from 61.25 meter so that the both will have impact velocity. This impact velocity will accomplish at 6 seconds. This impact velocity will accomplish at 3.5 seconds. Hopefully you follow the conversation. Now, problem number 4. So let me see. This vector is 5 centimeters. So I'm going to write 5 centimeter, 5 centimeter, and centimeter meter. And the conversion factor I give you, 1 centimeter is 4 meters. Centimeter cancel, 20. So A is 20 meter. Let's find B. B is from 0 to 3.5. So 3.5 centimeter, and again centimeter meter. 1 centimeter is 4 meters. Centimeter cancel. 3.5 times 4 is 14. So this is 14 meter. Okay, now I'm going to find the angle. How I'm going to find the angle? By using protractor. So this protractor going to give me the angle P. So angle P is exactly 20. I had no idea it was 20, but this is 20. Okay, so great. So I'm going to go ahead, draw a line, x-axis over here. So draw an x-axis. So how can I draw an x-axis? Let's at least try. Okay, so hopefully this is a straight line. Okay, x-axis. So I'm gonna measure 30 degree from here. So use I'm gonna bring it over here, and I'm gonna measure 30 degree. So 30 degree. For 30 degree, 20 degrees. So that's the tired. Okay. All right. So I'm gonna do this one. How many centimeter? 5 centimeters. So I'm gonna go 5 centimeter. At 5 centimeter, I'm gonna stop. That's my goal. At 5 centimeter, I'm gonna stop. So this is where I'm gonna stop. I'm trying to construct a parallelogram, and now I'm gonna do exactly 3.5 centimeter. So 3.5 centimeter from the head of vector A. 3.5 centimeter. So wow, this is exactly 3.5 centimeter. This is amazing. Okay, so 3.5. Okay, I'm gonna use this red card. Oh no, blue. Okay, now I'm gonna draw the resultant vector. Now this is a parallelogram, right? In the parallelogram, since this is 20 plus 90, so this is 110. This is 110. So then this has to be 110. Then this is 110 plus what is 180. Must be 70. This is 70. So this one is 70, but I'm not going to write it. This is 20. I'm going to cut this one half, and this is resultant. The resultant cut the parallelogram in half by definition. And so many of you are going to forget to put the arrow, and that would be no good. So I'm going to measure this one. I'm gonna, if I do measure it correctly, then it's gonna give me the size of this resultant 7 centimeter, 7.1 centimeter. I don't know what to say. 7.1 centimeter. So 7.1 centimeter. I just gonna say 7 centimeter. 7 centimeter. 7 centimeter times, you have centimeter, you have meter. 1 centimeter is 4 meters. Centimeter, centimeter, that's 28. So it should be a little bit more than 28, but I don't say 28 meter. Okay, now let's see the angle. This is exactly by measuring. We are not using the law of parallelogram, the law of sine, the law of cosine, the geometry, nothing, just by measurement. Measurement gives us the answer. So we did not use any formula. So this is 20, and if this is 70, this is 35, this is 35. So I'm going to write 35 over here. Since this one is the resultant angle, 20 plus 35 is 55. Okay, so I'm going to go ahead and I'm going to write, find the resultant vector. Resultant vector is 28 meter. And I'm going to write angle. Resultant angle is 35 plus 20, 45, 55, 55 degree. But this is plus minus 2, I will allow. Again, because this is measurement. This is 55. I will allow plus minus 2. Now let's see whether that makes sense. Oh, by the way, this one I asked you to put what c squared is equal to a squared plus b squared minus 2ab cosine theta. What is theta? What theta you put over here so that c is 28. You have to put, don't forget, head and tail. The angle between head and tail is 110. So you have to put 110 degree. Now let's see 28 degree. We get 28 degree. So now watch. So we're going to use the law of parallelogram. Law of parallelogram is r squared is equal to a squared plus b squared plus 2ab cosine c. So 20 squared plus 14 squared plus 2, 20, 14 cosine 55. So now let's see. Square root. This is all chalk. 20 squared plus 14 squared plus 2 times 20 times 14 cosine 55. Keep our finger crossed. 30. Okay, very good. And that's exactly within our plus minus 2 thing. Let's come back to the blackboard. The problem number 6 is a two-dimensional 2D kinematics problem. Mr. Barry is so this is dy, this is t. Mr. Barry is kicking a ball with 30-degree angle, 20 meters per second, right? That's the initial velocity. What I want you to find is at 0.25 second, what is the speed? At 0.75 second, what is the speed? By the way, the total time the ball was in the air is 1 second. Now, how do you find it? Velocity is Vx, Vy. So Vx is 20 cosine 30 is 8.7. 20 sine 30 is 5. Okay, now what are you going to do? You're going to draw the both component of the velocity. So both component of the velocity. So this velocity, I'm going to draw it bigger so that I can show this component nicely, and I can show this component nicely. Okay, this one is this one, and this one is Vx is 8.7. It doesn't change because acceleration at the x direction is 0, acceleration at the y direction is -10. So this one is also 8.7. So this one is also 8.7. Now we have to find this one. This one is equal in magnitude with this one. So this one is Vf is equal to Vi plus At. Vf is equal to Vi 5 because the y component always give you time minus 10t, right? T we know 0.25, 0.25. Okay, so VF is equal to 2.5. So if this one 2.5, this one must be negative 2.5. So we are almost there. We're gonna have to find the speed. Vxy is the square root of what? 2.5 squared plus 8.7 squared, and that is 9. If this speed over here is 9, uh, speed over here has to be also 9 because speed doesn't have direction, right? Velocity over here and velocity over here, they're equal in magnitude but opposite in direction. But again, speed doesn't have direction. Why velocity over here is negative? Because velocity over here is positive 2.5, velocity over here is negative 2.5. I mean velocity at the y direction. Okay, that was problem number 6. Now we're going to do problem number 7. Problem number 7 has to do with the two car moving, one with the acceleration and one with the constant velocity. So I'm going to give car y, this is car x. We're going to call this one 40 second, this is t, this is v, meter per second. We're going to call this one 20. I ask you to use this one 20 and put arrow over here because, oh, this is 40. So this is going to go a little bit more right here. I'm not not even trying to draw it to this scale. So you're gonna call car. This one is car X. This one is car Y. Okay, now what I want you to draw, I want you to write the equation for car X. The equation for car X, very simple. So this is car X. All right, what do we know? Velocity is VT graph give you distance. So the distance is VH. Area is VH. So area is displacement, B is time, and H is velocity, right? So D is time, velocity is 20 t. Okay, that's all I ask you to find. Great. Car Y. Again, this time the car Y you see is going to give you the half of BH. Area is half BH. All right. No integration needed. No integration needed. No calculus needed. Just algebra. Area is distance, half, B is time, and H is velocity. Now, this is technical. Please try to understand this. Now, for a V of t, right? V of t is equal to t. What does that mean? The height. H for height. The height is the y-axis. All right, the y-axis is velocity. Every point at the y-axis takes the time as the input, right? So that if you give the input, you get the velocity. Okay, and the half bh give you the SI unit. So then you can replace this one with this argument t. So d is equal to half t squared. All right, so this is for car Y. Now, if you want to do dt, of course you can do that. This one has this one starts with what? At 0 second, this one starts from 20. So let's say 0 second is 20 meter. So this is like this. At 0 second, this one starts with 0, and then this one like this. Okay, so I'm gonna say this one is I'm gonna put it over here. I'm gonna end the both of them over here. I'm gonna call this one 40. Notice that this is, I'm gonna call 20. Notice that at this location A, right? If you put 40, both of them gonna give you the same distance. Dx is equal to dy. I'm sorry, the distance by car X is equal to car Y. However, if you put 40.01, then they're not going to be the same. The car X is going to be 800.2, but the car Y is going to be 800.4. Okay, Why is that? Because the car Y accelerate, car X does not. Okay, that takes us to the next problem. I'm gonna do the car again, but this time a little differently. As you saw, we did it probably in the class. The car one is Toyota. I don't know what the Toyota U, and this is Porsche. This is U. This is Porsche. Red light. When red turn green, then this one accelerate with 3 meter per second square, and this one is 15 meter behind. The U pass Tesla at Porsche at location 1, but Tesla pass you, Porsche pass you at location 2. I ask you to give me the time 1 and time 2. That's it. So equation for this one is very easy. Equation for U is D is equal to VIT, D is equal to D initial plus VIT plus half AT squared. You are moving with constant velocity, so you don't have any acceleration, so 0. So D is equal to negative 15 plus 11.11 t. Okay, now this is Porsche. D is equal to VAT plus half AT squared. As you see that the Porsche is at rest. So D is equal to 0 plus 1.5 t squared. Now you can say the D is equal to D at this location. Okay, so then 1.5 t squared is equal to 11.11 t minus 15. So bring everything to the left side. 1.5 t squared minus 11.11 t plus 15 is equal to 0. So quadratic formula going to save us minus b plus minus b squared minus 4ac over 2a. So this one going to be 11 plus minus b squared, 11 squared minus 4 times 1.5 times 15 over 3. So 11 plus minus, you have 11 squared minus 90 divided by 3. So you get 2 root 11 squared minus 90. That must be something. 11 squared. So square root of 11 squared minus 90, and that is 5.6. So 5.6, I'm going to write 11 plus 5.6 divided by 3, 11 minus 5.6 divided by 3. 11 plus 5.6 divided by 3, and that gives us 5.5. This is 5.6, and this gives us 1.78. Okay, so this one is 1.78 second when you pass Porsche, and this one 5.6 second Porsche pass you. Problem number 9 is the vector subtraction, but I'm going to go very quickly because extremely tired. The distance from here to here is probably 200 meter, but doesn't really matter. What matter is the current. There is a waterfall here, so the current must be this direction, and current is how much? 0.9 meter per second. And what is the velocity you can move? You can move with 2 meter per second, I believe. 2 meter per second. Now, what angle will save your life? 90 degree will not save your life. 90 degree will be deadly. Okay, if Mr. Wari move 2 meter per second at 90 degree, he will not probably survive. So he has to make sure that this is the river, the current is this direction, velocity of water. Mr. Barry has to make sure that he gonna have to swim. If he swim downstream, what happened? He will die sooner. So he has to swim upstream So Vx component of its velocity, gonna cancel with the velocity of the water. And Vy component of its velocity will survive and take him home. That's it. So that's the story. I'm going to put the Vy component over here. And this is the water. So if this is 2, water is 0.9, you have to find SOHCAHTOA to find this one. So sine theta is opposite 0.9, hypotenuse 2. So theta is sine inverse 0.9 divided by 2. Sine 0.9 divided by 2, and that is 26.7. 26.7. However, if you write 26.7, you are wrong. The vec, this is how you measure the angle. At what degree you have to swim? At what degree you have to swim that you survive? Okay, so 26.7 plus 90, So plus 90. I believe 117. So 117. So 117. I don't like angle in fraction. So I don't know why, I like angle in whole number. Okay, now the last problem is the problem you've seen before. Okay, from exam number 3, I have a VT graph. I have something like, I have a VT graph. I have something like this. And what time the object is at origin? Well, very easy. At time 0, object is at origin. Well, what is the other time object is at origin? That's what I'm asking actually. So find the area over here. So this is BH. Okay. So this is half BH. So area is half BH. So area is half. B is this is 1 and this is 2. So this must be then half. So half. And H must be negative 2. 2 to cancel. So area is negative half. So if this is negative half and this is negative half, we multiply by 2. So area is negative 1. So area over here, this all together, this area is negative 1 meter. Okay, so try to understand this logic. Between 1 and 2 seconds, what is the area? Half BH. Half B is how much? 2 minus 1, which is 1. H is how much? 4. 2. Okay. Now, I need 1. I don't need 2. From 1 to 2 is 2 meters. I don't need 2. I need 1. Not positive 1. So negative 1, positive 1 cancel. So there exists time t when area is just 1. So that negative 1, positive 1 cancel, object is back to the origin. Okay. How can I find this? By using area is equal to half BH. Area is equal to half. B is what? Time. And H is velocity. So area is half time. Velocity is VF is equal to VI plus AT. VI is 0 over here. So VF is equal to VI is 0 over here. So we're going to say 0. Acceleration. Acceleration is 4 minus 0 divided by 2 minus 1. So acceleration is 4. Okay, 4. And then t minus 1. Why? At 1 second, velocity is 0. Very simple. Okay, so V. So area is half t minus 1. Why? Because it is just from 1. And V is 4 t minus 1. 2 goes to 4 twice. So you have area is 2t minus 1 squared. So what is the area then? Area is minus 1 plus 2t minus 1 squared. Okay, so 2t minus 1 squared is equal to 1. So 2 minus 1 squared is equal to half. The square root both sides. T minus 1 is equal to square root of half is 0.7. So t is equal to 1.7. So at 1.7, of course, the object is at the origin